Good talk. So we did the amplitude, and we did the midline. The period, you can start at the Y. I pressed the red. You can start at the Y, and you go past the max, past the min, back to that same height. And where does it happen at? 8. You guys have lines. Mine just decided to get rid of them. I don't even know why, but yours has lines on it. So the period is 8. And then the domain of every sinusoidal, unless the word problem?
Such that no element to the regular.
Yes. It goes on for life. My range, if you want to, I told you guys you could put this on your notes, but you can also remember it up here, so I'm going to put it here. My range for every one of these is sandwiched between my minimum and my maximum. So it's going to be y such that my min is less than or equal to, bless you, y is less than or equal to my maximum, yer. Now, please don't ever write min and max in your range. You have to put the actual values there. I've had people do that on the test. They write range, min is less than or equal to y. I'm like, no, you need to put the min and the max in, okay? So the range of this one would be y such that what? 1 is less than or equal to? Is less than or equal to? 5. Y is an element of rho. Now we need to go to our equation. So I gave you the basic equation. I said it was y equals a sine bx plus d. There was no c in it. If there was a c, I had to give it to you, but there is no c because there's no horizontal translation. How do I get the a value? Where does it come from? The amplitude. So we are going to go y equals plus or minus, that's an equal sign even though it made it look like not like it, 2. Now will we keep the plus or minus? No, this is where we sit. We're going to type it into our calculator as a positive. We're going to change our window and we're going to see if we get the graph. If we do, it stays positive, right, Mac? Mm-hmm. I'm way more important than your music. Like, I'm so interesting. Yeah, like super interesting. Like if I were on an interesting scale of 1 to 10, I would be at 100. No, I'm more interesting. Remember how we talked about this? Yeah, once or twice or 10 times. No, yes, yes. Okay, the B. How do we get the B? Is it the period? So do we put an 8 in there? No. If we see an 8 in that spot, we immediately cross that multiple choice out, right? Gonzo Alfonso, we do not keep it. I'm so full of like all these sayings right now. I'm just bubbling sayings out. It's intense. All right. So the period is 8, but B is not 8. B is, from our formula sheet, the 2 swapped, correct? So we look at our formula sheet. We have P equals 2 pi over B. The B and the P would be swapping, you know? And we get... Nope. 2 pi over 8, which is pi over 4x. And then what's our D? Midline, which is? Boom. Now I type in the positive into my graph. When I type the positive in, I get this graph. Remember, I would change my window from 0 to 20 for my x, and negative 2 to 6 for my y, and I would type in my y. Yeah. Because the period is 8, and this is not period. This is a B. You use the period, which is 2 pi over period, to get your B. It's a formula on your phone. Your B is never your period, or it would be called the period, which there's no such thing. We plug in the 2 and the positive, and it works. So we're not going to just cross that off and leave it. Now it looks like the plus sign has a period. Here, get it? All right, good talk. So we're going to rewrite it without that so that they have no question that we are brilliant and we have the right equation. I try and record. I try, but...
You ruined the first one.
I did. Ruined it or made it awesome? I don't know.
Made it awesome.
Okay, amplitude of this one is what? What's my maximum?
3.
Minus my minimum.
-7.
Divided by 2. So I actually get 10 divided by 2, which is 5. And then I check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And where are they meeting at? Y equals -2, which is my midline. If you don't remember that method, you can remember the formula, which is max plus min divided by 2, which is -4 divided by 2, which is -2. Same answer. We agree? Okay. The period is how long horizontally it takes to repeat itself. No, not answering it. So we start at the y-axis. Why does this marker not like me? Okay. And then we go past a max, past a min, back to that height, which is here. And I got a whole bunch of people stuck. They didn't know what the heck their x would be. And if you're on your phone, I'm not doing this for my welfare, I'm doing this for your welfare. So make sure your phone is away. All right. So if I count these, it's 1, 2, 3, 4, 5, 6 ticks gets me what? Pi. Something for your phone up top. 6 ticks gets you pi. This is how many ticks? 6, 7, 8, 9, 10, 11, 12. So if 6 ticks is pi, 12 ticks is 2 pi. Now is that my b value? Is that my b value of my equation? B value of my equation? No, that would be the p, right? So it doesn't actually, 2 pi goes nowhere in my equation. I'm going to use it, but it goes nowhere in my equation. My domain is x such that x to none of the reals. And my range? What's my lowest? Lower. -7 is less than or equal to y is less than or equal to 3. Okay, my equation. I told you it has to be in the form y equals a sine bx plus d. Okay, what is my a? Yeah, but we're going to put plus or minus 5 first, right? Because we have to figure out which one it is. Then sine. My b is not 2 pi, and if on the diploma, on a multiple choice spot, you have 2 pi. If you have that, will we pick that option? No, because we will know that the period can never be b. We agree? So we will just cross those ones right off, because those are going to be your common errors. Trust me, they're going to put the period in the b spot. They will. It's common error. So you just cross those off, and at least you got a 50-50 at this point, because they'll put 2 with the period as the b, and they'll put 2 with the b as the b. So it'll be 50 at 50, because when I'm making them, that's what I'm doing, because I know that that's an error that everyone does. So my b is going to be 2 pi divided by the period, because it's not a period, it's b. So I'm going to go 2 pi divided by 2 pi, which is 1. And then what's my d? -2. Do I have to go like this weird plus minus 2 thing? When you have a plus and a minus sitting side by side, what do you just have? Just the minus. Because the plus and minus are multiplied technically. So you don't actually need this sign. It'll always be what your midline is. Now everyone is going to type this into their calculator. Go. Type this into your y equals the plus version of this. So type in y equals 5 sine 1x minus 2. Every single person is typing that in. These just need to be whole bunch of space side and
How many pages? Or layers?
Okay. Stop. What are you doing? Okay, what is my x minimum going to be on my calculator? Negative 2 pi. What is my x maximum going to be? My x minimum is negative 2 pi. My x maximum is? What on here? What is it going to be? Positive 2 pi. Remember we discussed this, right? Negative 2 pi, positive 2 pi. My minimum looks like negative 8. I'm literally doing the screen that is in front of your face. And my positive y is going to be 4. We're literally filling in what this looks like. We agree? The exact same window. And in your y equals, you have 5 sine 1x minus 2, press graph. Make sure you're in radian mode though, right? Your calculator is not going to work well if you're in degree mode. So make sure you're in radian mode. Mode is beside the blue or the yellow button depending on what calculator you have. Make sure you're paying attention. So everyone has it in their y equals, and they press graph. And it should look like this. It should be going up, correct? From the y, so you know it's the positive. If it's going not like this, it's going the opposite, then you know it's the negative sign. Try that equation out. Okay, that's how you know if it's positive or negative. All right, what's the amplitude of this one? What's our maximum? 5 minus our minimum?
3. Negative 3.
Divided by 2. So it's going to be 8 over 2, which is 4. So I count down 4. 1, 2, 3, 4. I count up 4. 1, 2, 3, 4. And I meet at? Y equals 1. And that is my midline. I can also check it with my formula. So it's going to be y equals my maximum, which is 5, plus negative 3 divided by 2, which is 2 divided by 2, which is 1. Same answer. So which way is better? Neither. But you do have to, if you're doing this, like remember where I said the determine yesterday? Determine, you guys had to draw the Venn diagram or you had to do some explanations and some algebra to do it. If it said determine the midline and you just give me y equals 1, how much marks are you getting? You probably will get 0.5 because remember you got 0.5 if you had 18, right? If you want to do the graph root, you're going to actually have to show the graph root. Say this is the amplitude, say this is the amplitude, show where they meet and show the midline. You would physically have to show this graph, right? And say that this is the amplitude, and then amplitude, and show that they meet. If you don't have the equation and it tells you to determine, you physically have to show it by a graph, right? Determine means you can show it algebraically or graphically or some way. Yesterday was a Venn diagram, we could show it. Same thing. Or you could use the actual formula, right? And then the period of this graph, I start on my y, which is actually a min, so I'm going to go from a min to a min. This one, 1, 2, 3, 4, 5, 6 gets me to pi. 1, 2, 3, 4, 5, 6 gets me to 2 pi. So this one's actually the same period as the last one. So b equals 2 pi divided by the period. So it's 2 pi divided by 2 pi, which is 1. So if I find the period, I'll often find b right away so that I have both, so I don't mess up. The domain is x such that, x down to the reals, and the range is y such that, what's my minimum?
Negative 3.
Is less than or equal to y is less than or equal to 5. Now this one actually has a horizontal translation. So the equation is y equals a sine b x minus pi over 2 plus d. So my amplitude is plus or minus what? 4. Sorry, not my amplitude, my a value. Sine, what's my b? 1. X minus pi over 2, you don't change. They gave it to you. And by they, I mean me. And then, well, that's an aggressive amount of brackets. I kind of over bracketed there. Um, and then D is your midline, which is +1. So you're going to type this one in, and it'll fit the same window you just had. You'll type in the positive one, and you will find that you get the right one. Does it have to be positive A? Guys? No. So you have to check it each time. Then I want you to flip the page over. I'm going to give you 3 questions. This time, instead of giving you the graph and asking you information, I'm going to give you the equation and ask for information. Because I can either give you graph and ask for all the stuff, or give you equation and ask for all the stuff. Okay? So, here's your 3 equations. The first one is going to be y equals -2 sine 3x plus 6 minus 4. The second equation is going to be y equals 1/2 sine 2x minus pi over 2 minus 5. And then your third equation is going to be y equals -2 sine 1/2 x plus 4 plus 0.5. I want for all of these, I want the amplitude. I want the period. I want midline. I want max. I want min. I want the range. Okay, let's look at the amplitude of all of these. So if you have a phone out, we're going to put it away because I am more important. Trust me. Important. Important. Important? Important. Très important. Très. Very, very important. All right. So the amplitude is always just the absolute value of your A, correct? So even if your A is negative, there's still phones out, but I'm so important. Truly, I am. Okay, so the amplitude is the absolute value of the -2, so it's going to be positive, because remember, he doesn't like joining me. The amplitude is always positive. So what's the amplitude of 2? What is the amplitude of this one? 1/2. So it's going to be a very short graph, right? It's going to be 0.5 up and 0.5 down. It's going to be a very short graph. This one, what's my amplitude? It's 2. Amplitude is always what? Positive. Stop it. Calm. Cool. Collected. Pretty sure I'm not keeping this recording. Okay, the amplitude is 2 of this one. Okay, how do I get the midline? It's always y equals the what? The d value. So in this case, it's y equals -4. This one, my midline would be y equals what?
-5.
And this one, my midline would be what? Did you know, fun fact, that your amplitude and your midline gets you your max and your min without having to type this into your calculator at all?
That makes sense.
It does. So, if I take the middle line and I add to it my amplitude, I'll actually get the maximum. We agree? If I take the middle line and I subtract from it my amplitude, I'll get the minimum. So if I look at this one has a midline at y equals -4. And I go up how many? 2. And I go down how many? 2. So what is my amplitude at? Or my maximum at, sorry? -2. And what's my minimum at? -6. So if I just take my D, which is -4, and I add my amplitude, I'll get my maximum. If I take my D and I subtract my amplitude, I'll get my minimum. You have to start off with the D. Okay, this one. My midline is at what? Y equals -5. Then I'm going to go up 0.5. So what's my maximum going to be at? -4.5. Then I'm going to go down 0.5. What's my minimum going to be at? You see how I didn't even have to type it into my calculator? Now this one, my midline is y equals 0.5. Then I'm going to add 2 to it. Where is it? What's going to get me 2? And then I'm going to subtract 2 from 0.5 and I get -1.5. So my maximum equals my d, which is 0.5, plus my amplitude, so 2.5. And my minimum is my d minus my amplitude. The only other thing I asked for was the period and the range. The period's actually really easy from an equation. Why? Because you have a formula that tells you how to get it. So it says period equals 2 pi over b. I don't even know what you guys eat at lunch because you eat your lunch in period 2. So it's 2 pi over, what's your b? What's the b on this one? 3. So it's 2 pi over 3. This one, what's the period? 2 pi over 2, so it is pi. And this one, my period is 2 pi over 0.5, so it's actually 4 pi. You would have to put the 2 divided by 0.5 in your calculator without the pi. Divided by 0.5 in your calculator without the pi, and they'll tell you it's 4. And then our range is just from our min to our max. So this one's going to be y such that -6 is less than or equal to y is less than or equal to -2, y-er. This one is y such that -5.5 is less than or equal to y is less than or equal to -4.5, y-er. And this one is y such that -1.5 is less than or equal to y is less than or equal to 2.5. Y-er. So the difference between if I give you a graph and you have to give me all this information, or if I give you an equation and you have to give me all this information. So this little page in front of you is like a little summary of graphs on the front, equations on the back. Do you see what I'm saying? Okay. Today, we are going to do sinusoidal regressions. So it should be an easy day. Why? What's the only thing we're changing? We're going second, or stat, calc, C, which is a sine regression. That's all we're doing. We're picking C this time. Remember 4, 5, 6, 9, 0, and C? Today is C. Tara's high school class is planning a trip to British Columbia to study ecotourism next year. The students want to finish the tour on May 21st by watching the sun set over the Pacific Ocean. Tara found the following data for the current year and the following January. All times are in standard time, in hours, afternoon, as decimal values. At what time should the class be at the vantage point on the cliff? So, good, great. This is the one that I was talking to you about. This is example 3, where I showed you, you were like, oh, example 4 has a crazy chart. Well, look at this one. So example 4 has that crazy chart too, where it's the 3 pieces, right? So this would be your list 1. This would be your list 2, right? I'm not making you do this. Stop typing. Whoever's typing, quit typing. I'm not making you do this one. But this would be a long one. I just wanted to show it to you just in case they give you something crazy like this. So they might give you January 1st, 16th, 31st, and they give you like the actual dates, right? So people don't know how to type this one in. This one doesn't actually go into the list, right? It would be the days that would go into list 1 and this would go into list 2, right? Quite complex, but that's what it would do. Okay, you're going to get something more like this. Look at how much nicer that is. Huh? So much nicer. So here we have, in 2011, the Singapore Flyer was the largest Ferris wheel in the world. Now, why would a Ferris wheel fall into a sinusoidal category? Well, anytime you have anything that has a maximum and a minimum that keep happening over the same amount of time, it actually follows a sinusoidal curve. Now let me explain that to you. We're not going to do this one. I'm just going to get you guys to look. Put your pencils down, everything. Everything's down and you're just paying attention because I want you to see how this would make a sinusoidal curve. So if I make you a Ferris wheel like this, and I tell you the minimum is at 1, let's say. So at 0 seconds, it's at 1 meter. Okay? Then I say at 30 seconds, a little bit fast, it's at 21 meters. How could I get the middle height? How could I get the middle height of this Ferris wheel? Midline. How did I find the midline? What was the formula for the midline? Minimum plus maximum, or maximum plus minimum divided by 2, right? So if I go 1 plus 21, I get 22 divided by 2 is 11. So actually the center of the circle is just the midline. That's all it is. So this is going to be at 11 meters. And so is this. Right? Now if it takes me 0 to 30 to get me there, half of that's 15. So this here is going to get me 15 seconds. And this is 30 seconds. This would be 45 seconds. And then this would be back down to 60 seconds. Now, just so you know, in order to form a regression, they need to give you at least 5 coordinates. They can give you more, but they have to give you at least 5, right, Kate? Yes, 5 coordinates is what they have to give you in order for you to get a sinusoidal regression. Okay? How many do I have on here currently? 5. Now, I want to show you how this actually makes a sinusoidal graph. So this would be 0, this would be 1, this would be 11 meters, and this would be 21. So I'm literally drawing it at the same height, same scale as that, correct? Along the bottom, I would have 0, 15, 30, 45, and 60. And sometimes on your diploma, they literally make you draw this graph as a graph over time. Do sinusoidal graphs have curves, or do they look like mountains? When you look at the graph, do they curve like hills and valleys, or do they look like mountains on your graph? They curve, right? So should yours when you draw it. You'll see them on the graph as nice curved hills and valleys, and then you guys just like mountain them. That, if you do it as a mountain, it's not a sinusoidal graph, and you're going to lose marks. Okay? So, at 0, we're at 1 meter. At 15, we're at 11. At 30, we're at 21, so I'm just drawing the coordinates over time. 45, we're back down to 11. Then here, we're back down to 1. So what's happening is we're getting a curve, and a curve, and a curve, and a curve. You see how mine curved and it didn't make a mountain? We agree? So what's going to happen after this if I keep sitting on that Ferris wheel? It's going to repeat itself over and over and over, right? So it's making a sinusoidal graph. So anything with a max and a min that has a consistent period of time that it happens on will get you a sinusoidal graph. So pendulums will do that too. Max to a min, to a max to a min, to a max to a min, and it'll make a sinusoidal graph too. Another one, they say like there's a nail in a tire and the tire goes around. That would also make you have a sinusoidal graph because it's going to max min, max min, max min, keep going, right? Same, as long as you're driving at the same speed. Okay? So if I gave this to you and I asked for a sinusoidal equation of it, would you have to go like try and find the amplitude and the max and the min and all that jazz? Or if I gave you 5 coordinates, could you just get a sinusoidal regression? You could just get a sinusoidal regression. I technically gave you a table, didn't I? I gave you time in seconds, and I gave you a height in meters. And my coordinates are 0, 1, 15, 11, 30, 21, 45, 11. And then we're back to 60 and 1. Type those in and get me a regression. Go. What are we picking this time? What's the only difference? C. That's it. All right, so I'm getting y equals 10 sine. Now remember, it shows the equation like this. Y equals a sine bx plus c plus d. That's how it shows the equation on your screen. We agree, right, Sam? I'm really thinking there should be a phone on that shelf. Oh, there it is. Whew, my eyes were failing me. All right, so we know that it's in the form y equals a sine bx plus c in brackets plus d, correct? So we have to fill the values that they give us into that. We can't write a equals this, b equals this, c equals this, d equals this. Remember when we went on the written response that we did? That shows 0.5 out of 2 marks.
Could you do it and put it in the equation?
Yes. So, but ultimately you have to do the equation. So we go 10 sine, and then they would have to tell you what to round b to. And I'm going to say to the nearest hundredth. So 0.10x minus 1.57, and then plus 11. Okay, I want you to do some questions now for me. So this is what I want. I want to know at what height is the rider? At what do I have to give you if I want the height? The second, some sort of time, right? At time equals 122 seconds to the nearest hundredth. I want the height when the time is 122. If it errors you, what's your problem? Your graph's not big enough. Everyone figure it out. Nearest hundredth is how many decimal places? 2. It's 2. So you should be getting a height of what? Of 1.22 what? Meters. Now, paying attention. This is periodic. You have to watch yourself when it's a periodic function. When it's a periodic function, Ryan, you gotta make me test my punting skills with your phone. That's what you're testing me. See how far I can go. 40 meters, 1.22 probably. But anyways, so if I give you a height, what's the problem? Let's try it out. Put in a height of 20. Where does it go if I give you a height of 20? It goes in your y2, so type that in. What is my issue? There's actually an infinite number of answers, correct? This thing's going up, then coming down, then going up, then coming down. So how they have to ask this? They have to ask this in a way where they either limit your time, so they could say, at what time is the height 20 meters between 60 seconds and 90 seconds? Then you have to find the intersection between that, right? They could ask that. Or they could say, at what time in the first revolution, so that would be between 0 and 60, right? Is he at a height of 20 meters on the way down? So you would have this 20 meters would be rolling along here, right? They would be asking for this one. So they can ask for it in a certain way that they only get one answer, or they can ask for it in a certain way that they get two. They could say, in the first revolution, at what times is the rider at a height of 20 meters, right? I want for this, I want at what times in the second revolution the rider at a height of 20 meters. What times in the second revolution? You give me the times. So I personally made my x minimum be 60 and my x max be 120, so I could only see the second revolution. And then you can go second trace 5, enter, 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 and your first time is at 80. Lord, it's really. Your first time is 85.7 seconds. And then you have to go second, trace 5, and move over to the other one. Get close to the other one, remember? You can't just press it again, it'll just keep finding the same answer. And the other one is at 94.3 seconds. Does that fall between 60 seconds and 120 seconds? Yes. And then you would need a sentence, obviously. So I do want you to look at the very last page, the last example. I want you to do that one and answer it. It's this one. Yeah, this Ferris wheel one. So people don't know how to tell the difference between a quadratic and sinusoidal. So can everyone look up here? A quadratic, when you look at a table, say it's like 0. Weird. It's not working. Shocking. So say it's 0, 1, 2, 3, and you're looking at a table. With a quadratic, it'll start off with something low, like say 10, 20, 15, and 4. So my y's are going up and then coming back down, right? So that would get me a quadratic. How you can tell the difference between a quadratic and a sinusoidal is if you look at the table, we're going 49 to 295 to 541 to 295 to 49 to 295 to 541 to 295 to 49. We're actually making that curve, correct? So if you're going up, then down, then back up again, then back down, it's a sinusoidal regression. They don't even have to tell you. You should be able to tell. So here it said Jordy got on the Singapore Flyer at noon. So time noon would be time 0. And rode it for 4 consecutive rotations. His friend Yale was in a building directly across from the Singapore Flyer at a height of 400 feet. When was Jordy level with Yale? So they did it for 4 full revolutions. So we change our window to fit the data. And what do we always have to be in? Radians. Now, when I made it be between 0 and 100, I only see like 2.5 revolutions. So I need to see 4 full mountains, correct? So I try 150 and see if I can see it. That's 1, 2, 3, 4. 150 looks like it's a little bit more than 4, but I can see 4 full mountains, correct? And it wants to know all the times when Jordy is level with Yale. So is this X or is this Y? If we don't remember, we look up here. Our X is in minute, our height is in feet. They gave us 400 feet. What did they give us, X or Y? Y. So in your Y2, type in 400. Everyone's typing into their Y2 400. How many times is he seeing him? 8. We need to find those 8 times. Sometimes they'll say, how many times will Jordy see Yale? And the answer is 8. It's not even an actual, they don't want the times. They want to know how many times, right? And you'd say it's 8. Okay? So, we can give all 8 of them. I'm not making you do that. I want you to do this. At what time was Jordy at a height of 500 feet for the 5th time? I want the 5th time he was at 500 feet. So our Y2 is now going to be 500, and I want the 5th time.
Isn't that a phone rotation?
You're going to count. So 1, 2, 3, 4, 5. You're finding the 5th intersection.
Whoa.
Seconds or minutes?
No, it's not.
That is actually his. Minutes. So tonight, or today, I am posting the review for logs and exponents. Remember I said I'm going to give you a review, and then I'm going to give you the solutions to it, and if you just go through the review and look at the solutions and you're like, yep, got it, that is not studying, you will do terribly. You need to do the review on a separate sheet of paper and then check your answers once you've done them, okay? That's your homework for tonight, to start that.